I have now added the functionality into the assembler to deal with negative numbers. Now, we mentioned in a previous video a while ago about using 2's complement, so you can always go back and have a look at that video as a reminder of how to work 2's complement. But in essence, if we want to go from a negative number, say for example the number -5, and we want to go from -5 to a 2's complement equivalent in a 16-bit system, then all we have to do is add on 2 to the power of 16. So for example, if we had -1, we take -1 and we add 2 to the power of 16 to it. This is going to give us the 2's complement value for our negative number. So all we really need to do is go through the assembly language code. Everywhere that we find a negative number, which obviously will be in decimal, so it will be negative and then the decimal number, then we add 2 to the power of 16 to it to give the 2's complement. And we just go through that for the whole of the code. So now that we have a 2's complement number, there's no change within the actual design. So within the design here, we assume now that we're actually, rather than working from numbers from 0 to 2 to the power of 16, we're going to have half of them are going to be positive numbers and half are going to be negative numbers. And we're going to be using 2's complement. And you can see here that the options have been set up here as well for the multiplication in 2's complement and the division in 2's complement here as well. Now all we had to do was add a little bit extra code onto the compiler. So I'll quickly show you the code here. So it's a little bit small here, so I'll maybe try to zoom in a little bit. If you give me a second, I will open this up. I'll move over a little bit. So what we're going to do is find the negative numbers. So in this compiler here, a number could be represented by the number, for example, -5. So that would represent a memory location. It could also have the number #-5, and a #-5 doesn't represent a memory location, but it represents a literal number. So it means that we go through two options here. We either find a part that begins with hash and negative. So if it's hash and negative, then we take out the minus and the rest of the values, which are digits, and we change the digits into the 2's complement by adding 2 to the power of 16. Now the other option is that we don't have the hash, we just have the negative and then the number, in which case we go through the same process, but we don't have the hash value at the beginning. So that's the basic premise of it, and all I've really done is, rather than working through and adding this code through all of the rest of the assembly language, I've just stuck it right at the beginning, and I've said just open up the assembly language file, and everywhere you find the, for example, a -5, replace it with the 2's complement value. And that's us able then to deal with not just positive numbers, but negative numbers. So we'll go through a little example here. Now what I'll do is I'll pull out a little bit of code. So here's a bit of code here. So it puts -5 into R0, it puts -5 into R1, and then it adds the contents of R0 and R1, and it puts the value in R1. So if this works out right, it adds -5 and -5, it should get a value of -10. So let's go through here and we'll go through and do this addition. So let me fix the screen here so you can again see the screen properly. Okay, so that's the screen back into its correct position. So if I reset the simulation, reset, head in here, and I go edit contents and I open up the file. Okay, so this is the file of that assembly language code. In fact, what I can do is I can show you the assembled code as well. So if I click on here and we'll just run it, you'll see here we're getting the values FFFB, which is the value -5 in 2's complement, and FFFB again, the value -5 in 2's complement. So we've loaded that up and we'll run this, and it should run pretty quickly. And that's it, ran through and it stopped, so I'll stop that ticking. Now you can see here that we're left with the value of 5 here, but we're left with the value FFF6. Now if you put FFF6 and work it out in 2's complement, FFF6 would be the 16-digit value, which would represent the number -10. So it does work, and we can now deal with both positive and negative numbers. Now I will generate the full video for this and add it on to the course. Now what we want to be able to do from this is, now we've got access to negative numbers, it makes it a bit easier for us to generate our Breslau's algorithm. So let's go ahead and we'll crack on with that now.